Hey, last time we took a look at LeetCode's longest common prefix problem and some of its solutions. We looked at the runtime or the execution time. We noticed that all of those solutions ran so quickly that we couldn't discern a difference in terms of performance between those solutions. If you remember, all of the solutions ended up in this bar of the runtime distribution. A way that we could compare runtime is to use something like a system timer. Specifically, we could use System.nanoTime, which returns the current value of the JVM's high-resolution time source in nanoseconds. Implementing this utility in combination with some tests, we can look at runtime in nanoseconds, microseconds, or whatever time interval we think is useful. Let's take a look at the test setup in NetBeans. I've copied the solutions to the problem into classes, which you can see here. I have the horizontal scanning solution. I have the vertical scanning solution, divide and conquer, and binary search. And all of these solutions are held in their own classes. This way, we can simply instantiate an object of the class and then call the longest common prefix and then feed it an array. And here's our main method where we'll be executing the script you see here. Its general aim is to test a few cases where we expect performance to be poor. As pointed out in the horizontal scanning and vertical scanning solutions, the worst case scenario is when all of the strings are the same. I'll be doing a test where all the entries in the array are the strings flower. I'll be doing another test where all the entries are the word repeat, repeated a number of times. And I'll be doing another test where all the entries in the array are a string of A's and another where all the strings are strings of B's. So the script will run these solutions 300 times and populate an array called times with the execution or runtime. And the way that we're measuring that execution time is down on these lines from 34 to 39, where we create a long to hold System.nanoTime and call it start time. We then run the longest common prefix method of whatever class or solution that we're trying to test. We then create another long to hold System.nanoTime and call it end time. We just then subtract the start time from the end time and divide that result by 1,000 to convert from nanoseconds to microseconds. And we just populate the array that way. I'll give an example of running the script with the horizontal scanning solution. So I'll just run this. And here is our output. One thing to notice about the output is that there appears to be a decrease in runtime until about 100 or 150 trials, where it appears a floor is reached. Perhaps noticeable is that there are a few hiccups after the 100 or 150 trials. In an attempt to get consistent data, I'll be taking the 100 fastest trials of each set of 300 trials. This is an attempt to get rid of some of the noise and the stepping down phenomenon that we're seeing in the first 100 to 150 trials. And of the 100 trials that I'll be paying attention to, I'll be taking an average of those 100 times, so we have one single number to compare. As you may be thinking, this approach to testing isn't perfect, and I certainly don't claim it to be. There are probably better ways to do this, but this is one implementation of System.nanoTime that can help you get an idea of relative performance across solutions. Well, I'm going to run all of these tests, and then I'll come back and share the results with you. And here are the results of our arbitrary tests. It's a lot of information, so I'll break it apart based upon the size of the array fed to the solution type. You can see the test type here in the leftmost column, and the solution type across the top here, for cases where we feed 1,000 element array arguments to each solution. Remember, we were using evaluation cases where all of the elements in the array were a string called flower or a string repeat, which was repeated, or strings of A's and B's. Of the solutions provided by LeetCode, horizontal scanning appears to be fastest when we sum all of the runtimes together. There appears to be a little bit of variation from test case to test case, but overall, it appears that horizontal scanning is the fastest of our solutions. Another nice feature of evaluating runtime locally is that you can calculate things like a percentage difference. In this case, horizontal scanning, our fastest solution, is used as a basis to calculate percentage differences with other solutions. As the size of the array scales to 10,000 elements, we see that, again, horizontal scanning appears to have the fastest performance. The same can be said when our argument array is 100,000 elements long. So with our arbitrary test setup, I would lean towards the idea that the fastest solution provided by LeetCode is the horizontal scanning solution. This, of course, could be different in practice, depending on what our data set or what our arrays to be evaluated actually contain. If the data contained is similar to what our tests are here, then it might be a fair representation of performance, though I wouldn't necessarily count on it. One would need to know what they're going to be evaluating in practice. And that's it for today. I hope you enjoyed taking a look at the NanoTime utility offered by Java, and that you find uses for it to evaluate your code performance or code snippets, or that you find other clever ways to use it in your code. Please give this video a like, and if you're new, consider subscribing. Thanks for joining me. If you liked the video, consider hitting the like button, and if you're new here, consider subscribing for more coding stuff. All right, thanks, and this was a pleasure. And wow, did I mess that up?